Have you ever wondered how a computer can be smart? How does it learn things, almost like a person? Well, consider this. Let's meet a little friend of mine named Sparky. Sparky is a brand new artificial intelligence, or AI for short. Right now, Sparky is like a newborn baby, with a big empty digital brain, ready to soak up all the information in the world. It doesn't know what a cat is, what a dog is, even what a bicycle is. But Sparky is a very eager student, and it's about to go to school. The school of data. Its classroom is the vast world of information we give it. Sparky's journey starts with a simple question. What am I looking at? Imagine showing a baby thousands of pictures. At first, it's all just a jumble of colors and shapes. That's what it's like for Sparky. But inside Sparky's code, there are special rules called algorithms. Think of these algorithms as Sparky's own personal set of instructions for how to learn. They tell Sparky how to look for patterns. Our first lesson for Sparky is all about learning with a little help. This is called supervised learning. It's a lot like being in a classroom with a teacher. Imagine we want to teach Sparky how to recognize a cat. We can't just tell it that a cat has fur. We can't just tell it that a cat has whiskers. We can't just tell it that a cat has pointy ears. Sparky doesn't know what any of those things are yet. Instead, we have to show it. We gather millions of pictures. For each one, we give it a label. This one? Cat. That one? Not a cat. We feed all these labeled pictures to Sparky. It looks at every single pixel in every single image labeled cat. It starts to notice common things. It sees the triangular shape of ears. It sees clusters that look like whiskers. At first, its guesses are pretty wild. It might see a fluffy bunny and shout, "Cat!" because it saw something soft and with long ears. That's when our role as the teacher kicks in. We give feedback. Nope, Sparky, that's not a cat. This feedback is super important. Every time Sparky gets it wrong, it adjusts its internal patterns. It refines with every correction. It's like practicing flashcards for a test. After seeing countless examples of cats, and things that are definitely not cats, eventually you can show a brand new picture it has never seen, and it will say, "That's a cat," confidently. Now, what if Sparky doesn't have a teacher? What if we just give it a giant pile of data and say, "Figure it out"? This is a different kind of learning called unsupervised learning. It's like giving a child a huge box of mixed-up toys. Legos, toy cars, stuffed animals, and watching them start to sort things into piles on their own. The child might not know the words car or Lego, but they can see that some things have wheels and some things snap together. They find the patterns themselves. Let's try this with Sparky. Imagine we give it thousands of news articles from the internet, with no labels or instructions. Sparky starts reading through all of them. It begins to notice that certain words often appear together. Touchdown, quarterback, Super Bowl frequently show up in the same articles. Election, vote, president appear in a different set of articles. Sparky doesn't know what sports or politics are, but it can create its own clusters based on these word associations. This ability to find hidden structures is incredibly powerful. It's how online shopping websites can recommend products to you. The AI looks at purchasing history of millions of people. It sees that people who bought a tent, sleeping bag, camping stove also often bought those items. So when you add a tent to your cart, Sparky says, "Hey, you might also be interested in these." It sorted you into a camper group without ever being told what a camper is. There's another exciting way Sparky can learn, and it's all about trial and error. This is called reinforcement learning. It's a lot like how you might learn to ride a bike or play a video game. No one gives you a step-by-step manual. You just get on the bike and try to pedal. When you stay upright for a few seconds, you feel a sense of accomplishment. That's a positive reward. When you wobble and fall over, that's negative feedback. Let's put Sparky in a simple video game. Its goal is to move a character from one side of the screen to the other to get a cookie. Sparky has no idea how to play, so it just starts trying random things. It moves left. Nothing happens. It moves right. It gets a little closer to the cookie. For this, we give Sparky a small reward, a few points. This is positive reinforcement. Then Sparky tries to move up and bumps into a wall. For this, it gets a small penalty. It loses a point. Through thousands of tiny trials, Sparky slowly builds a strategy. It learns that a sequence of actions, move right, jump, move right, leads to the biggest reward of all, reaching the cookie and getting a huge bonus of 100 points. So as we've seen, our little friend Sparky doesn't just learn in one way. Just like us, it has a whole toolbox of learning methods. It can learn like a student in a classroom, using labeled examples to understand the world through supervised learning. It can be a detective, discovering hidden patterns on its own. Unsupervised learning. It can be a gamer, learning through trial, error, and pursuing rewards. Reinforcement learning. From a simple program that could barely tell a cat from a teapot, Sparky can grow into a complex AI capable of amazing things. It can help doctors diagnose diseases. It can compose music. It can explore distant planets. So the next time your phone suggests the next word, or a streaming service recommends a movie you'll love, think of Sparky. It's a little AI doing its homework, getting smarter one bite at a time. Science is cool,